Alright, so we're trying to practice with and use a new recording software. So we'll see if this works, how it works, and hopefully it'll give us a quicker way that I can record versus the Adobe Connect, which seems to have some odd issues in our lab at this point. Our lab's really designed for some live environment, and so trying to record in there is a little bit problematic. We don't have a static place to stay. We use some iPads to move around and do some other things. So one of the things we want to look at is very, very quickly, make sure you've looked through last chapter 7. We don't actually have a homework assignment per se in terms of pseudocode, but there's some ideas that we need to make sure of. We do object-oriented programming. We're starting to look at the idea of a class. And so the reality is a class is something we're all familiar with. We're just calling it something a little different now. So we're all familiar with the class of dogs and then those attributes that makes those dogs or those instances of dogs. So make sure you've read through this material. If you have questions, ask me. We can certainly go over any piece of it. I'd like to at least get into the homework and do a little looking at that very quickly. But classes have some interesting things. So a class has a name, data, and a method. In other words, they don't necessarily have to have all those. It can just have a name, but usually you have some method. So we have a couple of things we want to mention before our assignment that seem to be more iterated in Chapter 7 than in Chapter 6, although I think they're important, in that if we return a value in our pseudocode or in our code eventually, we won't start it with a void. It'll actually be like in the bottom half of this picture, if you can see the cursor here. So you'd have a string get name, whereas here you're saying void. So void is the return type, and then what void simply means is you're not returning anything back to the main program. So that seems to be an issue that people seem to have got. There is an issue of public and private access. So one of the advantages to object-oriented is we can hide data within our program from other parts of the program, and so we have to think a little bit about where that data needs to be used. The idea of inheritance. So we can inherit properties and attributes and methods of existing classes, but we can only utilize the pieces we want or the pieces we don't want. So inheritance is kind of an interesting thing. The idea of polymorphism. So a lot of these classes are written so that the class can deal with an object. So in the simplest example, it might be able to deal with a number or a letter, and it would operate differently based on whether you fed it a number or a letter. So that method then can work based on whatever the context or whatever the information that's being fed into it. So what are some of the advantages? Well, we can reuse and modify. So much like what we started with in Chapter 6, where we wrote little return modules or subroutines, and then classes and objects give us a little more advantage in that we now have these defined objects. So one of the things we like to think about objects is kind of like a blob. We feed in data into this blob, and something happens or something emerges. So object-oriented programming is what we've actually been looking at. It just now we're adding some more terms to it. So don't be scared about the terms you're going to hear, but let's think about our homework really quickly, and that I think will, once we see some of these ideas, I think they start to come together a little better. So I like using Notepad. There's other tools out there, and we can certainly look at some of them when we start writing code. One of the disadvantages to Notepad, at least for me, is that it doesn't give us line numbers on the left-hand side or right hand or anywhere, and at some point those will become handy for us. So you will see us try to utilize those fairly quickly. So you'll see like Notepad Plus or some other tools. But for what we're going to start with here, a very simple text editor is kind of an interesting thing. So rather than start with our own homework, I want to do something that I think will. So I copied and pasted this out of our textbook. If I get it broken down, one of the things that doesn't seem very easy. Let me turn on word wrap so we have word wrap enabled on Notepad, and by default it's not. It's under the Format tab. So this particular problem taken out of our textbook says, create the logic for a program that calculates and displays the amount of money you would have if you invested $1,000 at 5% interest for 1 year. Okay. So we know we need a start, and we know we need a stop. So one of the advantages I like here in Notepad is that I can go, well, and I know I need some details in between there. And so we know we're going to have some variables, so I'm going to indent in so I know that I'm within that program, and I'm going to say declaration. And so I know that I'm going to have a couple of values. And so your names may not match mine exactly, but I'm going to call it principal. So I'm going to declare a numeric variable called principal. In other words, that amount we start with. I'm going to declare one we're going to call balance. So at the end of the year, that amount of our account. And then I'm going to have one I'm going to call interest rate. And notice I can use an underscore. I can concatenate them together. And I'm going to actually give that a value already, right in the value. So I'm going to say it is equal to 0.05 or 5%. So the computer doesn't understand if I said 5%, but it does understand 0.05. Okay, so I've declared all these pieces, and we didn't ask for a loop. We didn't ask for anything else. And in fact, I might cheat a little bit here, and I know that this, my balance, we said was equal to 1,000. Okay, so now I've got 1,000 in my balance. We've got an interest rate, and quite frankly, we could write this in one step, and it is a fairly simple problem. But what I want to show is how we can put data into a subroutine and get data back out. So I'm going to think about my subroutine then. What is it going to do? So, well, I know then, and I made an extra space here so we have it all on its own. We know that our balance then is going to be equal to some formula and some module we're going to write. So to make life easy, we're just going to call it compute so we can see the difference. And remember that we're going to pass in some data into this. So we're going to pass in the principal, and we're going to pass in that interest rate. So when we call this function, and so this piece here becomes that function, compute balance, it's going to send to that function then 1,000, and then it's going to send that 0.05. So down here then, we're going to create our function. It's a numeric function, compute balance, and it's going to take in two variables. Okay. We know they're numeric variables, so we do know that. But we don't have to use the same name because we're just passing that value through there. We're not passing that that variable. So we're going to shortcut it. We could call them principal for prin. And we're going to pass in another numeric variable called interest. Okay. And then we're going to declare. So you notice we declared them in the beginning there. We're going to have another declaration statement, and we're going to declare. Now, obviously that's the same as what we declared up ahead. We could even use a different name, quite frankly, but it just makes sense to use balance. So then balance is going to be equal to that principal plus whatever a year's worth of interest is. Well, we're going to cheat a little bit. And so I could say plus principal times interest. But I'm going to cheat a little bit. I'm going to put it in one statement. So times 1 plus interest. So in other words, it's going to add that first because the order of operations. So it's going to add 1 to 0.05, multiply it by the principal, and give us our balance. And then because this function we return a value back, we're going to return balance. And so this balance here feeds back into here. Does that make sense? We feed this information into the function, and then the function feeds this return back into our program. So this is our module. This is our mainline program, and there's not a lot of items in there. It's pretty simple. So scroll down here a little bit. So our example has 2 functions. So let's look at an example that's got 2 functions. So this one's a little more complicated, but not horrendously bad. So we're going to delete all that. So let me break this up so it works a little easier on your screen and on mine. So chunk. Oop. Okay, so create the logic for a program that continuously prompts a user for a numeric value. If the user enters 0, the program's going to stop. Okay, and it's going to square and it's going to cube that values that you give it. Okay. So again, pretty simple. We're going to start with that idea, the same ideas we've had before. We know we're going to have a start. We know we're going to have a stop. And then in between them becomes our program. So we're going to declare some variables. Declare variables. And we can call this all different kinds of names because we are really doing pseudocode. And so we know we're going to have an inputted value. Well, let's just make life easy. Let's call it number. And we know we're going to have a squared. And we know we're going to have a cubed. Great. We know we're going to input a number. Input number. And we could get all fancy and put in, please user input your number and all these things in an output statement first, but we're just going to say input number. And then we're going to run a loop. So while number not equal to 0. So this loop is going to run as long as, and I'm going to indent this to make it a little easier to see. And then at that same, I'm going to have an end while. So a couple of pieces. This is that priming the pump, because we have to put an input in before that while loop can run. So while number equals 0, so the first thing we want to do is we know that at the end of this we're going to input number again. And then we're going to call 2 functions. Okay. So what functions are they? Well, I think we should probably call them. So we know we're going to use squared. So squared is going to be equal to, let's call that function square. And we're going to pass the value number to it. And we know we're going to have a function cube. So the value for cubed is going to equal cube. We're going to pass the number to it. Now we have one last little piece. It says output, and in this case we're outputting from the main line program, so we're going to have an output number. So we want the original number squared and cubed. So it's going to output all these pieces. So now we just need to build our functions. And so the first function down here then is obviously going to be that function of squared. So we're going to declare it. If I get the cursor to the right place. So num square. And we need a value inside of there, so it's going to bring in a value when you invoke that function. So we're declaring it right inside there, a num. And for convenience, let's just use number again because it's very easy to use. And so inside this function then, can't type today, we're going to declare num result. Close enough. Some value that we can do. So then that result is equal to that value we brought in, number times number. And then we return result. And that return result then means that it forces whatever we do here back into this value. Well, we're going to really cheat because I like to copy and paste. So the function for the cubed isn't much different. So I'm just going to copy it. And I'm going to say, well, func number cube. We still get in that value, that number, same number. Declaration, number result, no need to change that because it's just going to pass it back up. And the result, well, all we have to do here is add that third number. So hopefully that will give you a head start then on our homework. So if you have any questions, please email, ask. These are very, very similar to your homework, but work through them. There's not necessarily one right way to do these. There's a lot of different ways to do them. So hopefully that helps, and I will hear from all of you very soon. Thank you.